looking at the 2015 January Silver question, meeting time. So in this question, Bessie and Elsie are going to travel on the farm from the barn to their favorite field. And so Farmer Strong is going to have N fields, and what's going to happen is we're going to have M paths where Bessie and Elsie are going to travel on these paths. And for every path they travel, they're going to have a certain amount of time. And so for these paths, we can only travel from the smaller fields to the bigger fields. And what we want to know is we want to know the minimum amount of time for Bessie and Elsie to travel to their favorite field where they both arrive at the same time. So let's go look at the algorithm for this question. So the main algorithm we're going to be using for this question is going to be DP. But what we're actually going to do is we're going to take this as a graph question. So we're going to combine these two algorithms. And what we're going to do is we're going to create two 2D DPs. So one is going to be for Bessie and one is going to be for Elsie. And so for the Bessie DP, what we're going to have is we're going to have I be the current farm we are on. So I is going to go from 1 to N, and it's going to represent the current farm we are on. And then we're going to have J, and J is going to be the current time. So it's going to be the current amount of time that it's taken. So what we're actually going to do is we're going to take almost a knapsack sort of idea, and instead of using say value, we're going to instead use time. So time is going to be from 1 all the way up into the maximum time. And what we're going to do is we're just going to have these values, and what we're going to do is we're going to turn this into a Boolean array. So the value here is actually going to be true or false. And it's going to be true if we can visit farm I at time j using Bessie, or for the DPE, Elsie. And if we cannot, then it's just going to be false. So we're going to have this 2D DP. And again, we're just going to take a kind of knapsack sort of idea. So the way this program is actually going to work is it's going to be recursive code. So obviously you could write this code with more DP and for loops, but the code I'm going to show you is going to be recursive. And so what we're actually going to do is we're going to loop through, and we're going to check for every value of I. So we're going to have, say, DFS, I as the node. We're going to check if it's visited, two base cases. And then what we're going to do is we're going to loop through all of its children. And then what we're going to do is we're just going to recurse again. And what we're going to do is we're going to assume after we recurse that we're going to have filled out DPC and then 1 to N. And so what we're going to do then is we're going to loop through all of the possible times. So let's have time be max x. And what we're going to do is we're basically going to check. And what we're going to assume is since this current C is connected to I, what we're going to assume is if I can visit C in a total amount of time, so this is going to be a graph, and we're going to have I and C. And so we're going to assume if we can visit node C in X amount of time, then we can visit node I in X plus Y amount of time, where Y is the size of this trail or this path. So what we're actually going to do is we're going to loop through all of DP C and then J up to max S. And if that value is true, so if we can visit the value of C, we're going to make DP I and then X plus Y true. And so what we're basically going to do is we're going to build our way up. And when we build up, what we're going to do is we're going to basically keep assigning values true until we have DPI, where DPI is just going to be a bunch of true and false values. And since we're going to do this for both DPB and DPE, we're going to end up with two different arrays of the numbers and the times that it takes to visit the current barn. So what this means is DPBN and DPEN are each going to have a bunch of true and false values. And since they have to reach the barn at the same time, what we're actually going to do is after we run our DFS, which is going to be the bulk of our code, so after we run the DFS and then we calculate the values of DPI and whichever ones are true, and what we're going to do is we're going to loop through DPBN and DPEN, and if those values of DPB and I and DPE and I are the same, are both true, then that means we can visit barn N at time I, whether Bessie is going there or Elsie is going there. And so we're going to loop through this, and we're going to find the smallest possible value of I. And once we find that, we're going to return that value, and that's going to be our answer. So let's go look at the code for this question. So the first thing I'm going to do is I'm just going to define my variables. So I'm going to have long n and long m, and then we're going to create the ADJ list. We're going to create the DPs, and then we're going to have our input. So the ADJ list is going to contain 3 values. It's going to be the current field, it's going to be the time for Bessie, and then the time for Elsie. And again, we're going to be using an ADJ list because we're going to be using a graph. So what I'm going to do is I'm going to read in my input. And once I read in my input, what we're going to do is we're going to push back the values into the ADJ. And then what we're going to do is we're actually going to execute a special case for if there's only one node. So what this means is if the size of this is 0, then we're just going to mark this value, DPB10, as true. And once we've done that, we can DFS. So for our DFS, what we're going to do is we're going to run this, and then we're going to have our boundary condition. So the boundary condition is just going to be if this node has already been visited. And if it's already been visited, we return. If not, we're going to mark it as true. And then what we're going to do is we're going to loop through all of the children. And so when we loop through, what we're going to do is we're going to first DFS with the value. So we're going to DFS with the child's current barn. And then we're going to check. And the way we're going to check is we're basically going to tell if I could visit the DP next, so the barn next value, if I could visit this value, then what I'm going to do is I'm going to make the time of DP, our current node, and then the current time I, so this is the current time, and then we're going to add the next I. So what this basically means is we're going to add the time it took to reach DPB next 0I, and then we're just going to add I to that time, and we're going to notice that we can visit our current node in this time. So in the time of I plus the time it took to get to next, so the distance plus the time it took to get next, we're going to mark it as true. And if the same thing is true for Elsie, then we're going to do the same thing here. So the DFS over there is the bulk of the code, but once we finish that, all we're going to do is we're going to loop through max S, and then we're going to check all of the possible times. And what we're basically going to do is we're going to keep going until we find the shortest possible time where they are both able to visit barn N at that time. So if they can both visit barn N at time I, we're going to output I and return 0. And then at the very end, we're going to return impossible if we could not find any time where both of them could visit barn N at the same time. And that's the end of our program.